We're going to graph here in factored form. Oh, excuse me for that. The idea is that I am going to use some tips to take an equation along with the table and make the best possible representation of a graph without using any sort of technology. So I brought up factored form here real quick for a couple things. One is the A value. The A value will help you determining your end behavior, whether it's your regular old quadratic that goes up in both directions or if it gets reflected because of a negative A value. And I brought up this whole idea of the sets of parentheses. So this here, I've got three sets of parentheses. It would be a cubic because there's three sets. If I erased one set and now I've got two sets of parentheses, and now it'll be a quadratic. Okay. Another couple things that could help you or tips for graphing is you could find the x-intercepts. So that means you're going to put in y is equal to 0, or you'll take each of your factors and you'll set them equal to 0 to find those x-intercepts. To find the y-intercept, you would put x equals to 0 into your function and find out what y value spits out. You've got your end behavior, so by looking at the degree and your a value, you can tell what happens on the left side of the x-axis and what happens on the right side of the x-axis, if it goes up and down or whatnot. And then of course you got your turning points, and that is your nth degree. You go n minus 1, and that's going to be the most amount of turning points that graph has. So let's go through a couple of examples here. First thing first, I know that it's only got two sets of parentheses because there's a square there and a second square there. This is actually the fourth degree, which means with n behavior, it's going up on both sides of the x-axis. But because of this minus, you'd come through and you would kind of cancel that out. That negative right there is going to make it reflect. So I know my end behavior is down or down. This also tells me that 4 minus 1 is 3, maximum number of turns. I'm going to take x minus 2, set that equal to 0, and get x is equal to 2. And then x minus 4 equal to 0 and get x is equal to 4. What I just found were my two x-intercepts at 2 and 4. And I'm going to use a table, good old-fashioned table, to figure out the rest. Okay. Here's how I kind of figure. 0 is a must because I'm going to find my y-intercept. So I'll put 0 in for both x's. I get negative 2 squared, which is going to be 4. Negative 4 squared, which is 16. Multiply those together, you get 64. Multiply by that outside negative 1 and get negative 64. Okay, so there's my y-intercept. Now, what that's telling me is it's going to be way the heck down here on the y-axis. So I'm going to go with another point. Let's go 1. And what I'm doing is I'm just putting this in for x. So 1 minus 2 squared, 1 minus 4 squared. So negative 1 squared is 1 times 3 squared, which is 9, times that negative 1, and I end up getting a minus 9. Okay, so I'll go over to 1 and go to minus 9 right there. Okay, 2 I've already got the answer for it, 0. I'm going to put in a 3. Sorry, that should be a 2 there. That should have been my, I'll just erase that, start again. Again, I'm just putting these into my original equation, so let's go 3 minus 2 squared, which is 1. 3 minus 4 squared, which is negative 1 squared, or 1, times the original a value of negative 1. So I get negative 1 right there, so 3, negative 1. Again, I've got the answer for 4 at 0, so I'm going to put in 5. So 5 minus 2 squared, that's going to give me 9. 5 minus 4 squared, that's going to give me 1. And of course, the negative 1 from out in front, so that's a minus 9. Yeah, that's also nice as well. My idea is that I want to use my x-intercepts as boundaries. So I picked a number that is before my x-intercept, in between my x-intercepts, and outside of my x-intercepts. And I get something that looks like that. Kind of looks like the McDonald's M arches. Okay, matches up with my end behavior. They both go down. I've got 1, 2, 3 turns in it. So there we go. Kind of matches all those clues that I've listed above. Interesting. Okay. Well, kind of is the rest of my graphs. I knew I had more, but I guess I must have cut and pasted those pages to my notes. So if you want to check out some more notes, you go ahead and do that. But there's factored form.